Hello everyone and welcome back to my YouTube channel. In today's video we have trigonometry, one of the most important topics I would say in grades 9 and 10. I will explain everything to you in just 7 minutes. So how to find basic angles, sine, cosine and tangent. Unlike all other teachers, I won't start with the unit circle where okay, here are all the angles, find sine and cosine value of all of them. Of course not. We go step by step from the beginning. We need to know that everything we say today counts only if we have right angle triangles, which means if we have a triangle that has exactly 90 degrees. Let us assume we have a triangle, a right angle triangle. One of the angles, the one in the left corner, is angle theta. So everything we say today will be based on that angle theta. So what are adjacent, opposite, and hypotenuse? If we look at our angle, the side that is across the angle is called opposite. The side where the angle lies on is adjacent, and the longest one, hypotenuse. We will use that a lot. Now, of everything I will say today, the most important thing that you need to remember has 9 letters only. So, ka, toa. Basically, SOHCAHTOA will solve everything you need in trigonometry. Let us begin. So, S stands for sine. O is opposite, H is hypotenuse. So sine is opposite over hypotenuse. And then the same logic here. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Basically, so, ka, toa, sine, cosine, and tangent. Okay, let us revise it one more time. We have our triangle, right? The angle that we focus on, the one in the left corner, angle theta. Sine is equal to opposite over hypotenuse. Cosine, same logic, adjacent over hypotenuse. Remember, using SOHCAHTOA. Toa, tangent is opposite over adjacent. Now, let us see one example, okay? So we assume that we have a triangle, a right angle triangle, and let us say the sides of a triangle are 3, 4, and 5. Let us start with sine. Remember, sine is opposite over hypotenuse. Okay, opposite to our angle is 3. Hypotenuse, the longest one is 5. So sine of our angle was 3 over 5. Cosine, adjacent over hypotenuse. Let's start. Which one is adjacent? 4 over hypotenuse, 5. Excellent. So the answer is 4 over 5 using SOHCAHTOA. Finally, we need to find the tangent. Tangent, remember, toa, opposite over adjacent. Opposite is 3, adjacent is 4. So the final answer will be 3 over 4. Alright, now we focus on the most important angles. Angles that are multiples of 30 degrees, 45, and angles of 60 degrees. So basically, all teachers will just tell you to memorize it. I will teach you today how to actually learn it. Let's assume we have a right angle triangle whose angles are 30 degrees, 60 degrees, and 90 degrees. Remember this. Angle that is opposite to 30 degrees is unit 1. Angle that is opposite to 60 degrees, let's assume it's x. Hypotenuse, the longest one, is equal to 2. Now, right angle triangle, if we apply Pythagoras, we can see that x squared is equal to 3, which means x is equal to square root of 3. So basically, for a triangle that has 30, 60, and 90, just remember this. The sides are 1, 2, and square root of 3, radical 3. Okay, Now you can pause the video and find sine of 30 degrees and cosine of 30 degrees. Remember the rules: sine opposite over hypotenuse, cosine adjacent over hypotenuse. What could be the answer then? Sine of 30 degrees is equal to 1, which is opposite over 2, which is hypotenuse. Cosine is radical 3 over 2. All right. Let's try cosine of 60 and sine of 60 degrees. Try to pause the video and do it yourself. Remember, so, ka, toa. Opposite over hypotenuse, adjacent over hypotenuse. And of course, here it is. Sine of 60 degrees is radical 3 over 2, and cosine of 60 degrees is 1 half. Now, guys, if we summarize this, I want you to notice something very interesting. Sine of 30 degrees is 1 half. Cosine of 60 degrees is 1 half. They have the same value. And then again, sine of 30 is square root of 3 over 2. Cosine of 30 is cosine of sine of 60 is radical 3 over 2. Same value. All right. We have another one now. Angle of 45 degrees. If we have a triangle whose two angles are 45 degrees, then the sides of that triangle are 1, 1, and radical 2. Again, you can use Pythagoras to prove that, to check if it actually works. All right, let us find sine of 45 degrees. Opposite over hypotenuse. So 1 over square root of 2, right? And then cosine of 45. Again, 1 over square root of 2. But what's important? We know now that if we have a radical in the denominator, we need to rationalize it. In order to rationalize, we multiply radical 2 over radical 2. So that actually becomes radical 2 over 2. Instead of saying sine 45 is equal to 1 over radical 2, we say radical 2 over 2. Remember, that is the same thing. Same value for cosine. Tangent, we can get opposite over adjacent. And that's it for today. Thank you so much. Subscribe the channel, like the video. In the next one, I will explain the unit circle.